Hello everyone, I'm Hadi from Colorado State University, and today I'm going to present my research on characterization of shifts in hydroclimatology of US megaregions in response to climate change. The continuous United States, it's divided into large continuous geographical regions referred to as megaregions, centered on major cities. Most of the US population and economic growth has been concentrated in these megaregions. Climate change may exacerbate current problems in megaregions by negative impacts on energy, water supply, air quality, habitat um, preservation, ecosystem, and natural resources. Current megaregions planning strategies mostly focus to deal with issues such as transportations and underestimate the need to deal with future changes in climate and freshwater availability of megaregions. So, the objective of these studies are to investigate the effects of climate change on hydroclimatic conditions of US megaregions, assess and compare shifts in basic characteristics of US megaregions, and finally characterize shifts in climate types of US megaregions. For projecting changes in climate variables, the macroclimate dataset have been used. The macroclimate dataset includes 20 models which are downscaled for the United States at the grid size of 4 kilometers. As you see, future macroclimate models can be categorized in terms of changes in precipitation, temperature from current 1985 to 2016 to future 2070 to 2099. In this study, we have selected three climate models as wet, dry, and middle of these ranges. The second step is to project changes in hydrological components. The variable infiltration capacity model was implemented in this study to evaluate the hydrologic response of five climate models, which is a macro-scale semi-distributed hydrological model, and use the variable infiltration capacity curve to solve full water and energy balances. We obtained the weak model parameters from Obeidillah et al. 2014 that has been improved by Naz et al. At 2016. To calibrate the weak model, the simulated monthly total stream flow for each Hike 8 basin was matched with the monthly runoff from the USGS Water Watch runoff dataset. Okay, now we have the projected climatic and hydrological parameters for entire the entire the mega regions across the United States over the 21st century. We characterize shifts in hydroclimatic conditions as shifts in Boudico space. Boudico space, as it's shown, describe a relationship between the evaporative index and aridity index. It's called Boudico because he was the first person who was found in empirical relationship between aridity index and evaporative index. The evaporative index can be defined as potential precipitation minus stream flow divided by precipitation, or actual evaporation divided by precipitation. And aridity or dryness index can be also defined as potential evapotranspiration to precipitation. Shifts in Boudico space can be identified by a direction and magnitude. As a simple way, shifts to the right mean that the basin is getting warmer and drier, and shifts to the mean that the basins will experience less runoff. The Köppen climate classification divides the United States to main arid temperature, continental and tropical climate group. However, long-term changes in hydroclimatic conditions may cause megaregions to shift from one type to another in the future. To identify regions with shifts in their climate types, we applied the fine Gaussian SVM classification method to divide the Bodico space into three regions based on the Köppen climate classification and current aridity and evaporative indices, as you can see in the figure. Then we can characterize shifts in climate types using magnitude and direction of movement in the Bodico space. Let's see the results. We can show the same these figures for the United States megaregions. Houston is moving to the upper right of the Bodico space under the three climate models, meaning that it's more likely to get warmer and drier in the future. San Francisco, Los Angeles, San Diego, DC, New York, and Boston are moving to the left in the Bodico space under the three climate models, indicating that these regions are more likely to experience less arid climatic conditions in the future. Seattle is moving to the upper left in the Bodico space under the three climate models, meaning that the evaporative index increasing while the aridity index is decreasing. Our findings are sensitive to the choice of climate model. The results presented in this study under the dry, middle, and wet climate models are indicative of the effect of uncertainty associated with future climate change impacts on the hydroclimatology of U.S. national forests and U.S. megaregions. Changes in the spatial extent of climate type were also characterized by change in the area occupied by the Köppen climate types. The light yellow color show the region with no change in their climate type under the wet middle climate models. Uh, few basins show changes in climate classification. Under all three climate scenarios, some basins in DC, in New York, Boston are projected to change from continental to temperate climate type, according to the Köppen climate classification and using the SVM machine learning method. Under the dry climate model, most basins in Houston are likely to experience shifts in their climate types from continental to arid and from temperate to continental. Additionally, most basins in Atlanta are projected to change from temperate to continental, and some basins in Denver megaregion are likely to change from continental to arid climate type. The focus of this study as a conclusion was to shift in hydroclimatology of US megaregion in response to climate change. For the megaregion, the finding point out that Los Angeles, San Diego, and San Francisco may experience a decrease in aridity under all three climate models, indicating that these regions may become less arid by the end of the 21st century. Houston may experience more arid climatic conditions in the future by increasing aridity index under all three climate models. And the evaporative indices of Houston and Seattle are projected to increase by the end of the century under all three climate models, indicating that the evaporative loss of freshwater resources in Houston and Seattle are likely to increase in the future. The population of Houston and Seattle, we should note that is projected to increase significantly over the 21st century. These mega regions are likely to face more challenges in water resource planning and management in the future. Phoenix is also the mega region with the highest change in omega consistently across all three climate models, suggesting that the basic characteristics of Phoenix may experience significant change in the future. Under all three climate models, basins in Houston are likely to experience shifts in their climate types from temperate to continental. And besides, some basins in DC, Philadelphia, New York, Boston are projected to change from continental to temperate climate type. These findings highlight the need for developing a national development strategy that addresses climate change policies to improve robust economic growth and project on vulnerable natural water and food resources in the United States, and hence reduce negative consequences on the economy, society and environment. Hydroclimatic change combined with rapid population growth, urbanization, and land use change across the United States, and specifically in the mega regions, can accelerate future challenges in the mega regions and mm, specifically water scarce regions that may do not have mm, enough water and natural resources to overcome significant shifts in their hydroclimatology. Thank you so much and have a good day.